You may have heard that time runs slower in the quantum realm, but it's not just a figure of speech. Scientists have actually discovered that time slows down dramatically in this bizarre dimension, and it all comes down to something called gravitational time dilation. In simple terms, this means that the flow of time depends on the strength of gravity. The stronger the gravity, the slower the time. And as it turns out, the quantum realm has a pretty strong gravitational pull. Now, you might be wondering why this happens. After all, we've all experienced time slowing down when we're having fun and speeding up when we're bored. But this phenomenon is something else entirely. It's a consequence of Einstein's theory of general relativity, which tells us that gravity isn't just a force, it's actually a curvature in space-time caused by mass. When an object has mass, it warps the fabric of space-time around it, creating a kind of dip. The more massive the object, the deeper the dip. Now, this warping of space-time affects not just the motion of objects, but also the flow of time. The deeper the dip, the slower the time. This is why time runs slower on the surface of a black hole than it does far away from it. The closer you get to the black hole, the stronger the gravitational pull and the slower the time. It's the same thing in the quantum realm. The only difference is that we're dealing with gravity on a much smaller scale. The particles in the quantum realm are so small that they create a gravitational field that's incredibly strong compared to their size. This means that the flow of time slows down dramatically in the quantum realm, making it a sort of bubble where time stands still. Now you might be thinking, why should we care about this phenomenon? After all, it's not like we're planning on visiting the quantum realm anytime soon. But it turns out that understanding how time works in the quantum realm can actually help us understand how it works on a larger scale. For example, one of the biggest mysteries in cosmology is why the universe seems to be expanding at an accelerating rate. Some scientists believe that this acceleration is caused by a mysterious substance called dark energy, which is thought to make up around 68% of the total mass of the universe. Dark energy is invisible and has no direct effect on matter, but it does affect the flow of time. If dark energy exists, it would create a kind of anti-gravity that speeds up the flow of time. This could explain why the expansion of the universe is accelerating. If the flow of time is speeding up, then the universe is expanding more and more rapidly as time goes on. By studying how time works in the quantum realm, we can learn more about the properties of dark energy and test different theories about its behavior. It's the same thing with black holes. One of the biggest mysteries in astrophysics is what happens inside a black hole. Since nothing can escape from a black hole, we can't observe it directly. We can only study its effects on things around it. One way we can learn more about what's happening inside a black hole is by studying how time flows near it. If we understand how time works in the quantum realm, we can develop new techniques to study the behavior of matter near black holes. And who knows what we might find. It could revolutionize our understanding of the universe. In short, understanding how time works in the quantum realm isn't just a matter of curiosity. It could help us solve some of the biggest mysteries of the cosmos. Now, the quantum realm is a place where the rules of classical physics seem to be turned on their head. But there are some things that stay constant no matter where you are in the universe. One of these constants is the speed of light. No matter how fast you're moving, no matter how strong the gravitational field is, the speed of light remains the same. It's a fundamental constant of the universe, and it's one of the keys to understanding how the quantum realm works. In the quantum realm, particles can be in two places at once, and they can move faster than the speed of light. This may sound impossible, but it's actually a well-known phenomenon in quantum physics. It's called superluminal motion. Superluminal motion occurs when a particle moves faster than the speed of light, but only relative to a particular observer. In other words, it's an illusion created by the way we perceive motion. For example, imagine a spaceship that's traveling towards you at half the speed of light. As it approaches, it will appear to be moving faster than the speed of light. This is because the closer the spaceship gets, the more compressed it will appear to be. And the more compressed it is, the faster it will appear to be moving. But this phenomenon doesn't just happen with spaceships. It can happen with any object, no matter how small. In the quantum realm, particles can be in two places at once, and they can move faster than the speed of light. This is because these particles are so small that they exhibit quantum properties. They don't obey the same laws of physics that govern the motion of larger objects. Instead, they follow a set of rules that are completely different from our everyday experience. When we try to measure the position of a quantum particle, we find that it's spread out over a range of possible locations. This is called a wave function, and the wave function of a particle that's moving faster than the speed of light will be compressed as it approaches an observer. This compression of the wave function is what gives the illusion of superluminal motion. Now, you might be wondering why this matters. After all, if it's just an illusion, what difference does it make? Well, it turns out that this illusion has real consequences. For example, it can affect the way particles interact with each other. In some cases, it can even cause particles to disappear and reappear in different places. These are the kinds of phenomena that make the quantum realm so mysterious and difficult to understand. But they also make it such a fascinating subject of study. By exploring the behavior of particles in this strange realm, we can learn more about the fundamental laws of physics and the nature of reality itself. In conclusion, the quantum realm is a truly fascinating and mysterious place. It's a world where the laws of classical physics are turned on their head and where anything seems possible. From particles that can be in two places at once to superluminal motion, the quantum realm defies our everyday experience and challenges our understanding of the universe. But it's not just a place of mystery and wonder. The quantum realm is also a realm of possibility. It's a place where new technologies and innovations can be developed that will change our world in ways we can't yet imagine. Whether it's in the realm of medicine, energy, or communication, the possibilities are endless. But in order to harness the power of the quantum realm, we need to understand it better. We need to explore its depths and uncover its secrets. With each new discovery, we get closer to understanding the true nature of the universe and our place within it. So let us continue to explore the quantum realm and all its wonders. Let us push the boundaries of our knowledge and explore the unknown. Who knows what we might find? But one thing's for sure, the journey will be an exciting one.